class. This is the video tutorial for modeling the S60-117 secondary piston rod. We're going to model this, and it goes along with a family of parts that have similar features. So we want to set up our model to make sure that it's easy to change, and basically we have this same connecting feature in B2 where it has the through hole in the slot, and then we have common profile of the outside, and opposite end changes, and the length of the rod changes. So if we set up this model correctly, we should be able to make the dash 143 and 145 much quicker. So here we go. We're going to start off with open up SolidWorks, and we're going to create a new file. Part assembly, or I'm sorry, a part. And the first thing we're going to do is we're going to save it so that our autosave starts, and we're making the S60-117. And it's Rev 0, I believe. Okay, so what is our first feature? We're going to make this outside profile and revolve it. So we have sort of a rectangular shape with fillets on the corner. We have it change diameters. If we were to trace the edge across this profile, okay, so we want to make this like club baseball bat kind of shape. So what we need is a rectangular feature on one side with another feature in the center that's smaller in diameter, and then a larger diameter that has these two 45-degree chamfers on it. I'm going to elect to try to do all of that as one profile. The reason being is this is most likely a turned part, and when you get to the cam side, it's helpful to have the sketch of the outer profile that doesn't have interruptions in it, like the holes and things like that. So the machinist can extract that. So this is one of the few cases where I'm actually going to put the fillets on in the model and the chamfers. For milled parts, I tend to put that on last. So it depends on the design intent of your part. Let's go to the SolidWorks, and we're going to go to the sketch tool, and we're going to start on our front plane. Remember, always start your sketches anchored something on origin. Okay, so I'm going to go real quick. We got a line up, line to the left, line down, line across. If I zoom out, I got an angle, I got another line, another angle, and then we're going to come down, and then we're going to go all the way back to origin. Okay, so we have the rough outline of the features of this if we revolve it. The only thing we're missing is these two fillets. Okay, so once we get this thing to size, then we will put the fillets in as a fillet sketch feature. Let's start with our largest diameter, which is this 197. So 197 thousandths for the largest part. And we'll see if SolidWorks will scale it for us. So remember, if we're doing diameters, we want a center line, and we can make that center line. It needs to be coincident with origin and horizontal. And for this class, we're going to make that infinitely long, so it's easy to find. If you're trying to fit the screen, the hotkey F on your keyboard will center the screen. Now, I drew this at some arbitrary scale, so we're not sure what's going to happen, and you may have different results, but You can always hit undo and try a different approach. If we're dramatically different than what our finished part is, then we could have this thing go way out of scale. Okay, so it is quite a bit out of scale. So that's going to reverse my chamfers. So let's just leave that dimension. Let's go ahead and delete that dimension, and that was probably a poor choice. Let's go over here and let's do this other diameter instead. Okay, so we've got a diameter of 158. Okay, so I'm going to go from the outside edge to center of part, and it's 0.158 now. It may shrink quite a bit here. Okay, so it looks like SolidWorks went ahead and scaled a sketch for me, so that should be helpful. And we want to go to 3 place decimals. Okay, that rounded off. And on diameters, I don't always center the dimension, so let's just leave that where it is so you can read the number, otherwise it'd be right on top of this center line here. Okay, next dimension. We're going to go ahead and do this next diameter here. So if we go back to our drawing, it is called out here at 188. Okay, 118 thousandths. So again, pick this line, pick the center line, and then your dimension, and it's 0.118. Okay, that brings up the diameter, and you notice it's starting to turn black. Okay, so it's fully constrained. And then let's do our last diameter, which is, for me, I already had the center line selected, so it picked it up. You might have to select the center line here. And our dimension on that one was, we go back here, was 197. Alright, so now we have that shape. Now, these two angles here, they're supposed to be 45 degrees. We can dimension this one to vertical. And find a location where it lets you put in 45. Okay. I accidentally got a perpendicularity relationship there. That would work, but I think that was by accident. So just in case you didn't get that, we're going to go ahead and put in our 45 here. So those are both constrained to 45, and the size is equal on them. So we can't put an equal on an angle, but what we can do is say we want this line and this point over here on the chamfer to be coincident with each other, and what that will do is it'll make them the same height. Because we built this relationship, we actually don't need to create the height because it's dictated by the diameters and this coincident relationship we've got with the chamfer. So on the drawing, it's going to call it out. We won't have the dimension of 20 thousandths. The resultant should be when we're all done. Now let's do our linear dimensions. Okay, so we have 138 thousandths for the first rectangle width. So let's grab that edge. And set that. We need to set that to 3 place decimals. Looks like I forgot to set some of these others that need to be 3 place decimals. So we got 2 here, and we have this one as well, which are 3 place. So they should display what your design intent is for the tolerance. Okay, so we're fully constrained from origin around over to this corner and down to this corner. Now what we're not constrained is where's the linear length of this point and the overall length of the part. So let's get our next dimension, which is going to be from the base of the part to this corner here. Now I apologize for the rendering. These SolidWorks is not designed to do dimensions in isometric, and I haven't figured out how I can get rid of these without using a graphic software and breaking the ADA compliance. So this 790 thousandths dimension should terminate right at the bottom corner of this cylinder here. So if that's, sorry, that's a little confusing. Let's go back to SolidWorks and let's put in this 790 thousandths dimension. So we're going to go from base of part to the corner. We're going to bring up, and it's significantly longer than what's in there, 0.79, and it is at 2 place decimal. So there's a fair amount of tolerance involved there. Now, my model broke. Okay, what happened here? I made an interior feature longer than the entire part. That's okay. Let's just fix it. Don't freak out. You can hit undo, but had I done the longest feature first, it wouldn't have been a problem. But I can just drag this over. Here we go. Crisis averted. Okay. Now let's do our overall. Okay, and our overall length was 108. There we go, we've got it. Okay, so all we have left is some fillets here. Now occasionally, I'll warn you, the sketch fillets will break your dimensions sometimes depending on how you selected them. If you pick on the lines themselves instead of endpoints, they'll be okay. Okay, we're going to put in our fillets. And we have two different fillets. We've got a fillet called on the outside of an R 30 thousandths. It falls in two places because after we revolve this, it's an interrupted cut. So it's two different places, two corners. And then in two places we have 10 thousandths fillets here. Let's go put those in. We're going to use the sketch fillet command here. And we're going to select two corners. Why am I not seeing my menu? And we're going to set our fillet to 10 thousandths. And we're going to select the first one. And we're going to go ahead and accept on that. Okay, and then we're going to put in another one of 30 on the opposite end. And again, if you suddenly have a failure in this area and it's no longer constrained, it's because of how you selected your dimensions here. So you may need to redo the 138, or you might need to redo the diameter if you had selected on endpoints. So try to get out of the habit of selecting endpoints for things. They're harder to select. For a diameter, you want the entire line to be that diameter. And if you select on the endpoints, you could be, if it's not constrained right, you might be getting diagonal dimensions as well. So unless you really need an endpoint for something, select on the line segments for your dimensions. Okay. Alright, so we have this. This should be fully constrained now. I hit F button on my keyboard. And now we're going to go to features, and we're going to do a revolve base. So our revolve base should look like this kind of baseball bat club looking or mace looking shape. We're going to hit accept. Alright, and this is what your part should look like at this point. Now let's go fill out all the details. So we want to change our material to brass. And then I want you to go fill out all of this information. So you're going to have your part description, your part number, your revision, your material, your drawn by, your drawn by date or drawn date, and company. Company name. Okay, so it should be Sierra College. Drawn by dates, whatever date today is for you. This part was called secondary piston rod. Part number is S60-117. Revision 0. And the material was C36,000. Gotta make sure everything's capitals. Half hard brass, half hard to TMB16. Okay, so now what do we need to do? We look at our drawing and what are the features that we need to add. We've got flats on both sides of this. We got a hole and we have a slot. Let's put the flats in the back first. Okay, there's a variety of ways you can do this. I am going to sketch. And if you expand your menu here, you can pick on the planes. I'm going to sketch on the front plane. And we're going to remove material. With two rectangles. So draw arbitrary rectangles, try not to align them with anything initially. Okay, and now we're going to put in relationships. So let's align the left side of the rectangle with the edge of the part, because that's where it cuts off. So we're going to go highlight the vertical line, we're going to hold the shift key down and select the reference on the model. We're going to make those collinear. Okay. Hit accept on that. Now we're going to do the same thing with the other side. So no matter what happens, that edge is stuck to the part. Okay? They're not collinear to each other, they're collinear to the part, because we might need to modify this. Let's do the opposite, same thing to the opposite side. Okay? So now they're constrained on width. Whatever size this piece changes to for our other two parts, they will move with the model. Now let's move our diameter. Same thing. Gonna make those collinear. Okay, so without putting any dimensions on it, we have the outside boundary of three sides of each of those rectangles constrained to the model without any dimensions. Okay, now there's this width here. If we go back to our drawing, the width is 63 thousandths, and you notice on center line it's only 31 thousandths, and that doesn't math out. The reason is rounding error. This 63 thousandths is actually a 16th, which is 0.0625, which makes this 0.03125. The top number rounds up, bottom one rounds down. That is how SolidWorks does it. Actually, the ASME Y14.5 would actually round top number to the closest even number, and then it would split the difference. So for this, we're going to actually put in a 16th here, and we're going to put a 32nd in for the decimal equivalent for these two dimensions. Okay, so we can go from the width, let's put that in first, and we're going to put in 1 divided by 16. Okay, so that gives our 60 thousandths, but if we go up to 3 place decimals, it's 63. Then we're going to go off center line to center. And you're going to type in 1 divided by 32, which centers the feature, but at the tolerance we're working at, it doesn't exactly reflect it. Okay, so at this point, this should be fully constrained. We're now going to go to features, and we're going to go to extruded cut. And you notice I drew on the center plane, so it defaults to cutting one way and blind. What we want to do is change this not only to through all, but in both directions. And then it'll cut as far as the model is in both directions. We're going to accept that. Okay, now we have the flat, and we have the circular shape,